In this video, I'd like to continue working through the MathXL assignments that were given to us this unit. This time around, we're looking at simplifying radicals, homework number 5. Now, a radical is simply a root of some sort, and most of the radicals that we deal with in the Algebra 2 class are what we call square roots. And even though we don't write it, it's implied that there's a little number 2 sitting on the shelf of this radical symbol. And that's telling us that what we're looking for when we apply this symbol is a pair of numbers, or I should say a number that multiplies by itself twice, to equal the value that's underneath the radical symbol. Now, if there are numbers like 3 or 4 or 5, that means that we're looking for a number that multiplies by itself 3 or 4 or 5 times to equal the value underneath that radical. We always specify the index of the radical if the number is anything but 2. So if we don't see a number indicated here, then we assume that that value is 2. Now, sometimes we can use a calculator to obtain a result, and sometimes we're going to have to simplify these radicals by hand. And so I'll go ahead and check to see if a calculator gives us a nice result. And by nice result, I mean a whole number answer. So I'll switch over to the TI Inspire. We have these available in the classroom, and this software can be downloaded from the Software Center at Butler Tech. And of course, you can be using your own calculator as well. But on this one, I press the Control and the X squared key because that's calling the square root command. I don't know if you can see that in blue ink underneath my cursor here. But that square root symbol has been written, and there's an empty box inside that we're going to fill in with values. So I'll type in the number 484. And press enter, and sure enough the result is a nice whole number. So we can go ahead and report this as 22. The square root is 22. Now you may be looking at the second option and it says that the square root is not a real number, and that may sound strange to you, but let's recall that real numbers in our hierarchy of values actually contain lots of different types of numbers. So the result could be an irrational number, a number that has a decimal to it that continues forever without repeating. Numbers could be rational. That's where we can write them as a fraction, or if they have a decimal, it's a decimal that repeats or terminates. We've got the group of numbers called integers. Those are positive and negative numbers that have no decimal values following them. We have whole numbers and natural numbers as well. I usually lump these two together because whole and natural often are used synonymously. The only difference is that the whole numbers include the value 0, while natural numbers start at the number 1. But these are both essentially positive integers, numbers without decimals or fractions, and they are positive. The whole number group includes 0. So if this is the list of what we call real numbers, what are the numbers that are not real? Well, we're going to learn more about those in this class, but really, numbers that are not real are sometimes called complex, and sometimes the word imaginary is used. Complex numbers and imaginary numbers, those are the non-real numbers that we're going to focus on in this class. So essentially what's going to happen here is if we are ever asked to take the square root of a negative number, that's going to produce a non-real result. For example, I think you would be very hard-pressed to find a solution to this particular question. What is the square root of negative 1? Because remember, what we're looking for is a value that multiplies by itself to equal negative 1. And certainly negative 1 times negative 1 looks like it might be a good candidate, but when you multiply those together, we end up with a positive 1. There's no way that 1 times 1 would work because the same thing happens. And so some of you will say, well, what if you multiply negative 1 times 1? Doesn't that return the result negative 1? And the answer to that is yes, but now we're not multiplying a number by itself. We're actually multiplying two different numbers to obtain that result. So when we encounter this square root of negative 1, that's what produces these complex or imaginary number solutions. So let's try the calculator on this second example. I'm a little bit nervous because decimals are involved, but let's just see what we get. So again, Control X squared for the square root symbol, and we're going to enter 0.0169 and enter. And I had mentioned before that decimal values as a result to square roots usually cause a problem for us, and I should have clarified that because the decimals that I'm worried about seeing as a result are those that are non-terminating decimals. So this decimal terminates, it stops right after 0.13, and I know that it does because this calculator is programmed to show many more decimals beyond 2 if the calculated result displays that or returns that. So since this terminates at 0.13, I'm satisfied with that answer, and I would say that the square root of 0.0169 is 0.13. Clearly that's a real number, and in this case it happened to be a decimal, which is okay by the instruction set. So now we get into a problem like 3, and I don't think the calculator is going to help us here. For as advanced as these calculators are, if I try taking the square root of x to the 16th power, well, how about that? This calculator made a liar out of me. I didn't expect it to be able to do that. So surprise, surprise. If you're using the TI Inspire, I believe it has to be one with the CAS model system on it, then evidently this will simplify the work for you. Our handhelds in the classroom are not CAS enabled. They don't have the computer algebra system built in, but the software that you download does. So there's one added benefit to using this one. But let's talk about this a little bit more. Most calculators cannot do this, and so I was a little bit surprised to see the result. Why is the result x to the 8th power? Why is it that we can say that the square root of x to the 16th is x to the 8th? Well, again, keep in mind that the goal is to find two numbers that multiply by itself, I should say a number that multiplies by itself to equal x to the 16th. And if we think that x to the 8th multiplies by itself to equal x to the 16th, at first you may be a little bit concerned because we see two of these 8 values, and 8 times 8 is actually 64. But thinking back to the work we were doing last week, the two bases are the same, and the bases are multiplying together. If the bases multiply together, we actually add the exponents. And so 8 plus 8 does equal 16, and now we have a number that multiplies by itself, and the end result is x to the 16th. So I like x to the 8th as the answer here. Let's try to answer this one without the calculator first, and then we'll use the calculator to check our work. What number multiplies by itself to return the result 36, x to the 10th? Well, if I ignore this 36 for just a second, we have the square root of x to the 10th, and that's real similar to what we saw back here. So the question is, can we find something that multiplies by itself to equal x to the 10th? And maybe you've started to recognize a pattern or are guessing what the pattern might be, and x to the 5th would be a good answer. Essentially half of this exponent is going to be the answer in these types of problems, because x to the 5th times x to the 5th requires the exponents to be added, and 5 plus 5 does equal 10. So we've got x to the 5th times x to the 5th. That's going to return the x to the 10th part. So what number multiplies by itself to equal 36? Now that one hopefully was obvious to you, but 6 times 6 is a number that multiplies by itself to equal that. So since we were able to find a pair of numbers, or a number that multiplies by itself twice, we'll go ahead and report this as the result. The square root of 36x to the 10th is 6x to the 5th power. So let's check the calculator, see if it'll handle that one too. So we've got the square root of 36, x to the 10th power, and if we tap enter here, so this is kind of an interesting result. We've got 6 times the absolute value of x to the 5th. And I'm guessing that that was included because we recognize that the square root of x to the 10th must be a positive number, otherwise we would encounter an imaginary result. And since that's going to have to be positive, we should recognize that x to the 5th, some number raised to the 5th power, could potentially turn out to be negative. For example, negative 1 times itself 5 times in a row will be negative 1. And so before we can rely on this solution, we've got to recognize that x to the fifth must be a positive result before it can be placed, or I should say used as the radical of x to the 10th, because this is always going to be positive and x to the fifth by itself is not. So by putting the absolute value bar around that, that's going to restrict our results to be only positive results. If I'm being real picky, I would ask you to include this, but that's not my intention for this section of the class. And these absolute value bars are only necessary for exponents that end up being odd. So we'll go ahead and leave this one as it is, and I'm certain MathXL will accept that as it is too. Now in number 5, we start to see our first negative symbol, and I said earlier that the square roots of negative numbers cause a problem. But in this case, the negative number is not inside of the square root symbol, so we're actually okay here. I'm going to ignore that negative sign for just a second. In fact, I'm just going to leave it alone and treat this square root of 49 as its own problem that we're focusing on. Well, the square root of 49 is 7, and if we reincorporate the negative symbol that surrounded the square root of 49, then we can apply that negative sign in front of that 7, and we can call this result negative 7. One thing to keep in mind is that a square root symbol, a radical symbol, is really the same as an exponent. In fact, we could even write this problem as the negative number 49 to the 1/2 power. And when we're simplifying expressions like this, we always follow the order of operations, PEMDAS. And so if we follow the order of operations, exponents must be simplified, so in this case 49 to the 1/2 power, before we multiply or divide. And this is a negative symbol, kind of like a -1, that multiplies into this result. So that's the reason why we would apply and execute the square root first, and then the negative symbol after. It's all a part of the order of operations. You could check that with a calculator, but I'm going to move on here. This next result, well, the question does tell us that we need to use a calculator this time. So the square root of 18 is equal to some decimal that's not going to terminate. It never repeats either. And the instructions do want us to round to the nearest thousandth. So if I'm thinking of my decimal places, this first one is the tenths, then hundreds, and then thousandths place. So I need to go to the third decimal position in this result. Now the square root of 18, if I just press enter on this calculator, it reduces the result, which is okay. We're going to need that for future reference, but for now, I want the decimal value. So I'll just remind you that if you'd like a decimal value off of this calculator, you have to press Control and then enter. That's the only way you'll get your decimal result instead of a precise result. And so 4.242, 2 is the thousandths place, but if I look to the right of that, there's a number that's bigger than 5, or bigger than 4, so it's 5 or larger. That's going to round this last 2 up to a 3. So I'll call this 4.243. Please try the next one on your own. Use your calculator that you have at your desk or on your computer or on your cell phone for practice at home. Just keep in mind that cell phone calculators will not be permitted in the classroom.